Good evening, all, and welcome to Tinker Tailor Soldier Fry, the Let's Try program, here on the mighty Loading Ready Run Video Entertainment Network. My name's Ian Horn, and I'm broadcasting to you as per usual in these unprecedented times from the Crystal Gondola, the main palatial Tilty House studios here in beautiful downtown Victoria, British Columbia. Microphones. You can't live with them, you can't live without them, right? Dynamic mics, as a lot of people may know, are all the rage today, as was put in the schedule. I've noticed just a lot of people I know going out and grabbing themselves an SM, it was SM7? Yeah, SM7B, not even the 57s. Fancy microphones that need tons and tons of gain on them for them to be even heard because they're just so sensitive. Well, turns out there's a large number of products out there that can take care of that very problem. For example, let's you may have heard of the Cloud Lifter or the Fethead, or there are other lifters are available. But I thought to myself, you know what? I kind of want to see if anyone's been doing any of this themselves, because as you know, I like to DIY wherever I see or I can. So did some poking around on some forums, and turns out there's a rather popular what do you call those suckers? It's a rather popular model of one of these machines that that just fits inside of an XLR barrel. You can see it on the screen here, just right there. And it turns out it's extremely simple in terms of its circuitry. There is almost nothing to this thing. It's just a tiny circuit board, two transistors, four resistors, some wires, a board, and it's shoved into an XLR jack. So, we're gonna see if we can do this ourselves, because this the person who cracked open their amplifier and had a look at the circuitry decided that well, let's be really nice and provide a circuit diagram too. So this is what we're going to be following today, and we're going to attempt to make a microphone preamp. Ideally, this should give us around 27 decibels of clean lifting, but there is some work that's going to need to be done with it before we can get there. Also, turns out I don't actually have a dynamic microphone here in my studio, and I didn't borrow one from the office. So we're going to have to make do. I believe that we can use this this Rode. This is, what does it say? NTG2, which is in fact a condenser mic, but thankfully it's a condenser mic that is. Let me just open it up here. You can see you can self-power them using a battery, so you don't need to power them using phantom power, which is good because the circuit that we're going to be building is going to be sucking all the phantom power for itself to use. But on top of that, it's important to note, very important, gotta make sure it's nice and tight in there, how these mics work. Just for a quick refresher, condenser mic, like this one, is one that uses a small electrical charge to power the microphone, and then it reads the vibration between the diaphragm and the receivers to create an electrical signal. Dynamic mics, sorry, on the other hand, do this just all on their lonesome. They actually just use the pressure of the air to move the coil or the electric ribbon in certain cases on the microphone to make the electrical signal shoot out. So, where can you find that nice circuit diagram? Well, if you do some searching on, good God, I don't have that up here. Let me just give me 1 second here, and I think I can grab the thread for y'all. Why the heck not? And let's just input that into the chat for you all. Nope, that's into the wrong thing. Open the chat window, and hopefully don't blow anything up. There we go. Check that thread. That's going to get you most of the information that I am working off of right now. All right. So, what are we going to do here? Well, first of all, assuming this works, let's do a quick change. So, both of the microphones we've been using tonight so far have been set at 90 gain on a handy recorder H4n from Zoom. Notoriously, the NTG2 is known for being rather quiet, specifically when paired with the H4n. So hopefully we're getting a good baseline as to what this what this sound is going to be like. All right, so let's swap back over to the overhead mic. Boop, there we go. Because I'm going to need to make some changes to this. Well, not this mic, but the mic cable is going to have a fun time, because we're going to chop it in half. I do love getting to do that. I just realized I should have brought in a cutting board for my work surface, but I guess we'll just go right onto the table today to start with, because that's going to be okay. It's going to be okay. So we don't need to chop this yet, but we'll just make a chop, I don't know, probably I'm going to say here, because this seems like a good place. And then we'll put everything inside a nice little project box, and then it'll just be a box in the middle of the cable, which will be perfect. So let's take care of that. Now the problem is, it's not really a problem so much as it is just a thing to note, is that to do this sort of thing, let's bring up that circuit diagram again, just in case, just so I can give you some information here on that. Oh, no, I can't. Okay, so that circuit diagram has, oh wait, you know what, I'll just do it. I'll do it myself. There we go. Hey, look at that. It's our good friend circuit diagram. It's our good friend breadboard. We're going to need that. So the circuit diagram doesn't have much to it, if you'll note. All we've got on here... Oh, actually, I can read this off my own screen. What am I doing to myself? Terrible, terrible stuff. So we're looking at on there. We're going to need our 2 resistors of the value 22,000 ohms, which we've helpfully pre-selected. We've got 2 resistors of the 68 ohm variety, which is an interesting one. And we have what's going to be our problem here are these little friends here. These are Toshiba N-channel JFETs, and those are the transistors that we are going to be using here. So I needed to do a little bit of research beforehand to find out which are the dump, the gate, and the signal. Signal? No, source. Source, yes. Because of the way transistors work. You know, you get your source, which is your voltage comes in, and then you have your gate, which is controlled by another form of another voltage source, and that controls how much current is actually getting through the transistor. Source and drain, thank you. SD and G, gate. The trouble is, these things are tiny. They're very tiny. They're very hard to make properly. So what we're going to have to do is we're going to have to examine the performance levels of these little guys and find what's called a matched set, something that's going to be close to the same levels in a certain measurement that so that they react in the same manner. Same speed, and we don't get any sort of weird phasing effects. Now to do that, it's a pretty simple little fix. I've been, again, doing some research this morning, and what we're going to be doing is measuring what is called the... Ian looks over at his notes. Was it the IDDS, which don't ask me to remind you what that is. But yeah, it's basically little bit to do with the speed of how these things work. So let's empty these out. Let's get to categorizing and building ourselves up a little testing situation here. So I'll move these to the side. Get these are all where they need to be. Ah, IDDS is the drain current. Thank you, Drissett. That's right. So I've already prepared a 12-volt power supply here. That's going to be, let me, wait, did I get 12 or did I get 9? Hold on, I just need to go underneath to check. That's already plugged in, so handy. That is 9 volts. So 9 volts is more than enough for us to be able to work with here. It just needs to be nice and consistent. Hey! Oz's made a pizza. That sounds delicious. So yeah, let's hook this sucker up here with the with some power. Let's get that negative in and get the positive in. I wonder if I have a way of locking that. Oh no, I don't need a way of locking that down. It's pretty good as it is. Okay, let's get those in there. Okay, now there's a pretty easy procedure for doing this here. So what we need to do is we need to connect the voltage to drain. Well, let's set up a nice little situation here. I'd say let's go here. 1, 2, starting at 10 and going 11, 12, 13. Let's also do it with the flat side facing me so that I always know which way is which. Okay, so where's my extra wires? I don't often get to play with the breadboard, so it's nice when I can break this out for a little bit of fun. We generally don't, no, not we generally don't, but it's not often that we get to get this this electrical engineering. Okay, so voltage plus to drain. That's going to be the leftmost because we're looking at drain, gate, source. Someone who has worked in power engineering, not signal engineering, there's a reason you're preferring JFETs for this over BGTs or other things. Iris, really only in that I believe that the JFETs are what's used in this particular piece of hardware commercially. If we keep on this particular road, we might end up using something, we might consider something different in the future if we want to go into designing our own preamps. But I think this is going to be, let's pull that power out just for a second. Yeah, also apparently these ones are really, really clean sounding, these particular Toshibas. Just again, so in case you're looking, these were not easy to find actually. A 2SK170BL is what we're working with here. Maybe we'll put that here. Nope. How about here? Good, that'll do. All right, so we got our power hooked up. Next we need to connect the gate and the source together with a 100 ohm resistor. Gate and source go together. So let's get anything smaller here. In terms of my wires, they're all huge. They don't need to be huge. Let's see here. Gate. And let's send that to, I don't know, 20? Or let's go row 20. And the other one, so what's the final assembly plan on this? 3D print a case, solder the parts together and hot glued into a wad. Arclight, we got ourselves a small little project box to put it all in when we're done, and we'll just run the cable in each side, provide some strain relief with the patented zip tie maneuver, and then yeah, then we should be good. Okay, God, there was a source that I could find that does metal project boxes with the appropriate cutouts already done for XLR ports. If I'm making more of these, I definitely want to get a few of those because those seem real good. Analog power, electronic can be like black magic to more digital minded keys. I say that as a power person, RF is black magic. Ooh, no, I find them both fascinating, but I have not done nearly enough to learning to consider myself anything more than a complete dabbler in this. Okay, so we've got those connected. Now we need to get our friend the 100 ohm resistor. Red and green, interesting choice for incoming power. Which is which? Red. Let's go with red. Because blue is the other option, and I had too many blues, and I decided I wanted to use green. Take that. All right, let's go 20, and then this goes to ground. Great. Boop. Okay. Now, why did I leave it up like this? Because we're going to measure the voltage across that resistor. And we'll see how it works. And what we're going to do is measure the voltage across the resistor, which gives the IDDS reading, 1 volt equaling 1 or 10 milliamps of current. And Bob's your uncle. I'm going to keep my station clean here. Let's put away some of these wires. Now the idea is that we're going to map out all of these resistors. That's really cool, Ashburn. Bob was my uncle as well. I guess technically he still is, but he is also technically not living, so I don't know how to resolve that. Judge? Okay, let's bring up the multimeter, and let's hope against hope that I've got enough battery power on this sucker to get me through it. I think this is all going to be under 1 volt, so... Oh, come on. Let me do that there. Where can I put this so that it's visible? Hey, there we go. So let's push this forward a bit more here. And then I'll take the reading off the front of the TV. All right. Let's get ourselves some juice in there. Don't let it go for too long because we don't want to change things. And that's looking at 0.975, I'm going to say. So just put that down as 0.975. Okay, let's get that one out of there. And then we'll add that there. Now what we're looking for is... oh, do I have the multimeter back? Woops. We're looking for values that are within 5% of each other, is my understanding. So let's hope, because apparently it can be like winning the lottery if you get too many of these things. I was hoping that we'd be able to. Whoop, there we go. That's in there now. Hoping we'd be able to get enough matched pairs out of this 10 to make a few of these, so we'll see. Oh, that one's all over the place. Also, my hands are all over the place. Okay, let's just make sure everything's in there nice and tight, and double check again. 1 and 2. So I'm going to say it's 9.95 or 9. Yeah, ooh, that one likes to bump around a lot. But let's say 1.02 once it gets pretty worked up. Nope, don't move these around, Ian. 1.02. We're going to call that, which is a fairly significant difference there. All right, FET 3. Let's bend the pins ever so slightly just to give it. Go back to engaging power afterwards. Power in. Let's take our readings. 1020. 1021. 1.021. I'm gonna put a little asterisk next to this top one though, and that was kind of twitchy. Because we don't, if it's gonna jump around a lot in use, maybe we don't want to use that one. But that's, yeah, this one's consistent, and I like the your face at unexpected flyback voltage. This is really the sort of thing I'm from the outside super into, because this is the sort of thing that's going to lead towards circuit bending and pedal creation, which could be problematic for my wallet and time. Next to no input current. Thank you, UWD John. That's a good explanation as to why they're used for this sort of thing. 0.838. Pretty solid there, but that is way out of line for everything else. But good to know. 0.838. All right. So far, I think we've got enough that we can at least do the one today, but I wouldn't necessarily, until I actually get to look at those numbers, I don't know if we've got enough to do more than one, but we also aren't even halfway through, so. Yeah, this is the thing about electronics and just about everything, is you don't necessarily need to know what you're doing, but it helps, and you might learn something in the process. 747 like a rock, he says, as it jumps to 748. Okay. 747. That's, wow. That one's off by more than anything else we've got so far. Let me say, it also helps when you've got a really good community of smart people who are watching your program and don't tend to judge you too much. Or at least only tend to judge you based on your safety practices, which I'll allow. Okay, let's get those in there. Oh, come on. Ian needs a sip. Click. Ooh, this one looks promising. 938, 939. 938. Nice. Tonight's beverage, by the way, is Category 12's Critical Point West Coast Pale Ale. It's crispy and fun, and I enjoy it. Low noise, all noise. Square wave goes brr. But I find it fascinating right now, specifically at this very moment, that we are just the range of differences that you can get off a part that theoretically should be mostly the same. Yeah, to follow up on what we were saying about the 838, 839, I'm going to call that 840. That's really good. We got another matched pair. In fact, that's probably our closest match. That might be the one we use. Yeah, we did some really good. We hit some really good numbers here today. But yeah, someone was mentioning that that this was a JFETs are used in audio because of the low noise. The problem is that there's lots of variability in them. So unless you test them by hand like this, you don't know that you're going to get a matched set. And so they tend to be used, at least for my reading, in they tend to be used more in handmade audio products because people go through the efforts of testing, matching, and then sometimes reselling. Like if I were to have bought these as a matched pair set, I think they would have been probably another order of magnitude more expensive than they were. And that's assuming that these are even. They said these were legitimate Toshiba parts, but apparently that's something else that can be an issue. Yeah, Dresden. Like I paid, I think, about that for the 10 that I have. Ooh, this one's all over the place too. No, okay, it's good. 1068. Point 068. Wait, is that 1.68 or 1.068? I think that was 1.068. It was 1.068. Haha! Double check for correct. So I did have it correct. Good. Yeah, 1.68 would seem really off from everything else here. Oh, I'm gonna have to be very careful when I move this book elsewhere so that I don't end up jostling these. I'm actually going to put them on a different surface entirely once we're done. Okay, what are we at here? What do we got? 0.827, I'll call that. Oh, that's also good. 827, okay. Well, final one. What do we got here? Need a magnetic whiteboard for them? Oh god, no, that seems like those would start drifting way too easily. The whiteboard in this room might not be a bad idea. Let's consider that in the future. In you go, and survey says 9991. Okay, well, gonna write down a big ol' 1.000. Yeah, I mean, Scotch tape is probably the correct thing to do. Just like we did in Ask Master in the most recent episode of Loading Ready Live, available now on YouTube at youtube.com/loadingreadyrun. That's not confusing at all. Okay, let's get that out of there. And let's put to the side our anything that's going to cause me to possibly jostle these little transistors out of the way. We can probably put the power supply away too. Keep this around just in case I need. Actually, no, we'll use this for mapping out the circuit, shall we? Now, how am I going to do that? Do I want to do it in such a way that I can jam? I don't know if I can jam the little wires into the breadboard, but we might be able to make a connection in another way. Yeah, we're gonna let us hecka breadboard this out first. But first, let's choose our two bits, shall we? We've got a couple options here. So what do we got here? We got 975100. Geez, I mean, these seem to be. Oh, but that one's the twitchy one, so I kind of want to avoid that one if possible. So I think the one I'm going to want to use, let's go with 827. Yeah, 827 and 848. Oh, no, wait, sorry. Let's go with 840 and 838. Those seem to be the closest. And then we've got 827 and 838, which should probably be. Oh, no, we've got 838 and 838 and 938. Yeah, we still got those two to work with. But this is definitely our best match here. So I think we go with these two. The rest get to go on a slight journey to a different tabletop in case I bang this one. And I'll tape them down. Okay, right. That was surprisingly a lot easier than I thought it was going to be. I guess. Oh, wait, that one's still in line 747, not 838. Oh, yeah, 102 and 1021. You know what? You're right. Let's do that instead. Open them back. No, I'm going to keep it where I'm at because we can avoid the twitchy one, or we might be able to use the twitchy one if we want it. But yeah, this one, not twitchy. This one, all good. And I referred to 747 as 838. Yeah, I made a mistake there, but 747 is still in its line on the sheet there. Everything's correct there. Real gamer count, I would like to, but unfortunately we don't have enough significant digits on that multimeter. I mean, I guess we are technically... No, we're not using the same number of significant digits. We're just using the same number of digits, which makes things unfun. Okay, let's bring up... Well, so we've got the diagram up there, and I've got the diagram down here. Or let me bring it up on my side here so I can look at it. Active ribbon. There we go. Okay, so we come from in, and we're going to need resistors now. Red, orange is the... Oh, can never remember my resistors. What we're looking for here, we're looking for 22K ohm. Thank you, DuckDuckGo, for just putting the codes directly in the top line. That's red, orange. So those are going pin 2 and pin 3. All right. Well, let's start on. How do we want to do this here? We got 3 pins. Ground just goes to nothing. 1 goes to nothing. So, okay. Oh, did they use the wrong... I think they posted a... Well, you know what? We're working on this. We're working on it, and we might need to swap the ground and drain. You're right. Well, we'll find out. We'll find out. But UWD Johnson, you might be correct on that. Bad beer rots our young guts, but vodka goes well. All right. source followers. Okay. So I'm working this out in my head here because as I said, I'm not versed as I should be on breadboarding. Let's throw that in. Yeah, let's use pin 1 for pin 2 and pin 5. Pin 5. Or for pin 3, shall we? So let's get those into B and C because we need the inputs on those. Okay, then that goes to the resistor. The resistor goes to ground. So let's send these both to interesting stuff, America. Thank you. Okay. So where do I want to send these resistors to? Ground's going... Oh, they want to go to ground. Okay, well, aha! The D and the S are swapped in the schematic, so we'll need to keep that in mind when we're working. Thank you, the Meerkat, for the information there. All right. So, yeah, let's send things to the ground channel. Which in this case is just going to be, let's just send it directly to out. Right? Right. Seems good. If I set anything on fire, then I am really doing something wrong here. We should not have enough voltage to set anything on fire, and if we do, sad panda times. Okay, that's in pin 1, pin 2, good. And those cross into there. Okay. Next up is going to be... I need to write that down, otherwise I'm going to forget every time. Where's my pen again? Over here. Swap D and S. D/S, and of course I'm looking at DGS on that. D, G, and S. Great. Just needed to give myself some notes. Oh wow, that doesn't come across at all. There we go. Good enough. Okay, let's just bring that, make that a bit smaller there. Whee. Hey, Fortnite, it's about to get down. All right, so going off the ground, let's send these guys to 15, 16, and 17, and 15, 16, and 17 on the other side there as well. Okay. So, so we're looking at the G pin is going to go to the resistor on that side. G is, oh, you know what? Nope. What I could just do is I could actually just flip the diagram around, but or flip the JFETs once we get everything properly wired up. But let's just do it ourselves. Okay, so G is going to go to in hole. Yes, 1. Perfect. So that's going in there. Okay, and we'll do the same thing on the other side, but with the other guy there. All right, that works. Why not test to make sure it works with the next closest match pair once you know it works? Hey, that's not a bad idea, Dressen. We've certainly got time so far. Things are moving pretty quickly. Okay, so we're looking at now a need for more wire. There you are. Here's the wire box. Alrighty. Oh, whoops, wrong hole there. That would have caused some consternation. Okay, and then we're going, D will go to pin out. So that's D goes, well, we might want to use let's use a red for that and a yellow for the pin 2. 2 and 3 seems good to me. So we'll make out 2 is going to be red, and out 3 will be green. Wait, yellow. Okay. So that's going, so D is going out to pin 2. Send that all the way to the phantom zone over here. 45. And we'll do the same with yellow, pin 45. I'm going to take that all the way down to the bottom. If it'll reach. And it does. Great. Well, maybe not the bottom, but we'll go to row 60 for the yellow. Okay, let's go to row 60 for both of them. Just to keep it symmetrical. Whoop, whoop. There we go. Okay, those are wired up. Now we got to get our Ds on. So the Ds are our resistors, and those are, and by Ds I mean S's, because the diagram is swapped. So resistors then go to also ground. That's easy enough. Let's span the whole system here again. Okay, ground, ground to ground. There we go. Everybody's happy with that so far. Yep, D's connect to each other, and by D's I mean S's. Okay. I think that's the circuit. I think that's the circuit right there, which means it's time to don't. Wait a minute. No, I've only wired up. No, I did wire up the 2 there. Yeah, 1 and 5. Those are going to be our out points. Okay. So if the input resistance of the receiver's mic is 1.5K, then you should get an effective voltage gain of 1500 over 66 equals 22, which is around 27 dB, which is exactly what we're looking for. Thank you for checking my work there, UWD. That's really cool. Drains on camera left. Dresden, I did some research on these earlier, and specifically on this particular, the Toshibas, camera left is the drain. That's the D, so that is correct. So, yep. But that's the difference, is that we need, this circuit diagram needs to have the needs to have the transistors rotated. So that's why we're okay there. Everything's fine. We're all good. Everything's where it should be. Now I need to make a cable into two cables. Using a, where is a good, there's a good nipper for this. Okay, so this is the mic end, so we want to leave mostly cable there. And I figure about a foot. It's enough space, I think. Because you don't want it to go too far, but you also don't want it to be, you don't want your box right in the middle there. So let's pull out the camera bit here. And you know what? Let's just set this over here for now. So we can start working here. Cutto! Hey! No going back now. These wires back. On this breadboard, you need to connect both ground blocks. Oh. No, I think everything's... Ooh, wait, I'm not complete. That's right. That's right. Or did I? Yeah, I've only sent things to the ground. No, I didn't. Everything's correct. I did send things correctly. These are our output terminals here. And these two up front here are our input terminals. In fact, just to make it very clear on myself, so that when I go about soldering this together, boop, 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 boop. Give me your answer, boop. I'm half crazy, all for the love of boop. It won't be a stylish marriage. We can't afford a boop. But you'll look sweet on the seat of a boop built for two. Hopefully that's enough to keep the bots away from that. I don't know that it matters which side it's on. So you're either going to get... You're introducing noise either way. And you're probably... Yeah, you're probably right that we want it on the other side. But you know what? Look, we can turn it around if we want to in the future. All right, now comes the fun part of remembering which pin goes where on a... or which pin is what on an XLR jack. I know that some of them are labeled. This one helpfully is, but I can't see it. Well, we're going to need to unscrew it anyway, so let's get into it. I mean, we don't actually have to unscrew it, now that I think about it. But, you know, this will be helpful in discovering. 1, 2, 3. Pin 1, pin 2, pin 3. Helpfully labeled, if you can in fact see that on your television screens at home. Does Beej know I'm in here cutting up his cables? Arclight, these are my cables that I'm cutting up here for this reason. For that very reason, in fact. Uh-oh, what have I done? I have inadvertently stuck my... Good job, Ian. You stuck your XLR in there. How do I get that out? With pliers, obviously, but I don't have any on hand right next to me. Oh, it's so close to being in line with itself. Dang it. Okay. Be right back. Just need to grab... Oh, wait, needle nose pliers are here. Haha. Good job, me. Also, let's open up a window, because it's extremely hot in here right now. Okay. Whew. Please excuse any street noise you may be experiencing for the next small while. Hey, there we go. Now it's out. And now we can put it back in properly. There we go. So wait, what was it? 1 is top left. Which I'm thinking pin... One of my friends used to work at the BBC newsroom crew way back in the day, and among cables, there's one which everyone was told, do not touch this. This was the main one that carried the composite from the camera arrays to the rest of the studio. Now, as a leaving prank, they covered this cable up and put a identical spare on top. Oh no! Just before the 6 o'clock news, one of the runners went, check. Ah! That's a good prank. That's a fun prank that I approve of. No one gets hurt there. Just someone just has a massive coronary. That's all that's going to happen there. I don't like this screw. It doesn't want to go back in the way it's supposed to. There we go. I just need to pull it down a bit further. Apparently that's not so bad. Okay, you know what? Let's just use our continuities. Strip some wire here. Ooh, or actually, here's my Molexes. Wonder if we can just shove things down and get continuity that way. If we can, that would make me very happy. Ooh, 602. Well, let's see if I can shove this in, or if we're going to have to make some sort of a splice here. Get in the hole. This seems like a bad idea, but also I don't care, so... you know what? That might be enough, but I don't... You know, it seemed like a dumb idea. So maybe we should just, you know what? That's in there pretty solidly. You know, let's see if we can get the other... Let's see if we can get another one in there. If we can, that's, saves us some time. Okay, that one doesn't want to receive... That is a very brittle piece of plastic, so that's not going to work so well. Okay, you know what we're going to do? Now it seems like a good time for us to take a short break. So I'm going to get up, wiggle the footsies around, swap the fluids, do the stuff we need to do on break, and you're going to do the same, because break time for the streamers, break time for the viewer. And we'll be back with more Tinker Tailor Solder Fry, where we can hopefully get this mic tested up and then maybe work on soldering it up into a more permanent solution. Either way, don't go away. More Tinker Tailor Solder Fry after this. Welcome back to Tinker Tailor Solder Fry here on the mighty Loading Ready Run Video Entertainment Network. We are in the process of making an inline op-amp for dynamic microphones. And we have the thing made up here mostly. We just need to get it in such a state that we can plug a microphone into it. And I think I know I'm going to do that, and we're just going to chop up some of these little Molex friends here, because why not? So we're going to need one more. We're going to need pin 1, which I want to be green. That's going to be the ground. We're going to need a brown pin. That'll be our pin 2, our cold. And our third pin will be red. That will be pin 2, the hot pin. And let's just cut these open and solder them onto the ends of these. Why not? Why not? I say. dare I say, why not? I should really get some alligator clip systems for these so that I can connect directly up to things. But hey, for now we have these. And now that I have the ability to crimp my own, perfect. All right. Stripping. Strip a bit, and then we'll do the same on the other side, on the jacket side, rather, or the cable side, rather. How far do we want to go here? Click, click. That seems like a good enough space. There we go. There's one. Two. 3, 4, 5, 6. Okay, and then let's do the same thing with these end pieces here. Ooh, that one just wrecked that red piece. Let's try that again, shall we? Yeah, we're going to want to trim that later, but I think that's going to be doable for us. We can make that work. We can make that work. As ugly as that is, we can make that work. Okay, put this over here for now. And actually, I'm going to do the thing I should have done when I was running out of the room earlier, and that's grab myself a small soldering surface. Be right back. Bamboo cutting board! You're a decent soldering surface. Bamboo cutting board. Never ask for more. Ooh, although we do have to ask for a bit more in terms of our soldering iron. Well, I mean, there we go. That's about all we got. Folks, thank you so much for your ridiculous generosity that you keep sending my way. I'm absolutely in awe. I want to thank Femerl, F-M-E-R-L, if I'm pronouncing that correct, Femerl, for sending me a goddamn soldering iron. I guess you got sick of seeing me play around with that TS-80 on stream. This literally just arrived today, and I haven't had a chance to unbox it, but I'm very excited. Good you're here. Thank you so much. This is it's nice to have nice things sometimes, I think is the best way of putting it. So now I need to take good care of this. Yeah, good one. I'm very excited for this very good boy. Girl, person, soldering iron. This is not a person. Okay. That goes there. Got all the fun parts of it. You've had this model for almost a decade now. Well, that is a ringing endorsement in my book. Then I like things that last for more than a decade. Nice to have both sponge and the spring, but I like the spring is important because it's the sort of stuff that doesn't shock your iron the way that the spring that a sponge can. So yeah, once more, thank you so much, Emerald. This is a lovely and perfect gift, and you'll be seeing it a lot on this here program, I am sure. Okay, let's get that in there. Oh, wait a second. Having to update USB software and USB pen doesn't ring right with you. I mean, that's fair. I'm still a fan of the small form factor, but it's nice to know that I have something that's always going to work, and or at least track down why if it isn't. All right, nice little station there to hold that on. Put the sponge in there for now. Don't need to wet that down just yet, but it's good to know that it's there. Get a chisel tip on that bad boy. I mean, ooh, what has this got here? It's an interesting tip. Okay, anyway. Ooh, hey! Don't see these every day. It's what was it, a DIN connector of some sort? It feels like a piece of German stereo equipment, which is what I'm saying here. Okay. Stage manager Rob, we are aware of my shirt, and not much we can do about it. Sorry. It is DIN. Good DIN. Okay. Just gonna give that extension cord a bit of work, and then place that behind you and go plug it in under the desk. Now that I've got an actual bench, it's nice to have an actual a high quality iron. Yeah, I've come around to the chisel tip lifestyle after reading a couple articles on the natures of tips and why you should use certain ones and why the needle tip is usually often not the correct choice. All right, plugged in. Let's put that in there. Not on screen. Oh well. You'll get to see the tip. That's the important part. 750. That seems high. Good God, that goes. Good God, that goes. Holy moly. Okay, well, that's not going to take any time to heat up, which I'm very happy about. Let's, ooh, should get my continuity meter so I know which one is which. So I know the big empty brass, that's going to be our ground, but is red hot? Red is on the male side. It's pin 1. Continuity. One, two, red. Perfect. One is red. Okay, we're all good. Oh yeah, 750 Fahrenheit. That sounds more correct. 750 Celsius seems impossible without possibly turning everything off in here. Make sure to tin the hell of that tip before using it the first time. That's a good idea. Let's do that right now. Let's give this a lot of... Nice. Clean there. Yeah, 750 is way too high for anything. Hold on. Ah, okay. I need... Actually, I looked up my soldering iron here. 361 is where my my solder melts at. So let's, you know what? Let's go 362. This is not a bad interface. All right, let's bring that on a bit there again. Just a bit more. Coat it over. And then clean that sucker off. All right. Okay. Where am I going here? Right. Red to red. So let's just tin that up there. Come on. Okay, good. Let's tin up the white while we're here. Good. And let's get some on the ground too, because why the heck not? That seems a bit more sensible in terms of heat. But it does not take long to get going. Okay. Right, where's my holder? I don't have many good holders, but this will do. Get in there. Oops. Well, that will ruin that part. That's okay. Okay, and we just need to make this connect, so it doesn't need to be particularly good. This is just for all we're doing here. All we're doing here is just putting together something for purposes of testing. Here's a set the 750 and works great. Yeah, you know what? I might just want just a bit more. Just a wee bit more. Okay. Get in there. Make them come together. Is it still on? Oh yeah, it's still on. It's just taking its time. Because you don't need to be any hotter than you need to be. Okay, there we go. That's one. It's not great. Yeah, 375 seems like a good number. I'm trying to be all cool and not, God damn it, that's a terrible non-joint. Let's try do this a bit better. There we go. Now we can actually get some pressure on there and make a connection. Much better. Okay, that'll do. That'll do for now. Again, we're not looking to make anything permanent here. This is strictly for test purposes. 450 says Compact Disco. Super Mario Compact Disco. Now, if anyone remembers Super Mario Compact Disco, then you got a keeper there. Come on. Become molten. You can do it. I believe in you. I believe in you. Nope. You did not become molten enough. You terrible... I need to get rid of this string in here. This is really chapping my style. Or is it champing my style? Like one does at the bit? Who can say, really? God, yeah, if you want to just ruin some people, start using the phrase champing my style and see who notices. Get in. Good. Okay. Apply heat. Let physics do the work for me. Let physics do the work for me. Let physics help me out here. Oh, come on! Okay, how do I increase the temperature on this iron? Wow, use this button to select and change settings. Pressing and holding will start the adjust mode. Adjust. Enter. No, let's go 70. Enter. 5. Enter. Go up. All right. Okay, there we go. Changing 75 to 800. Press the enter down for at least 1 second. Set up. So it really likes being hot. Okay. Enter 75. Enter. Okay. Don't know why I'm not able to change that temperature easily. But we still need to solder things, so let's keep at it. Cephadilus, it is definitely in Fahrenheit, which is not my preferred temperature, but is the temperature of the way it is currently set up. So we do with what we can. And we deal with what we can. Okay, you know what? That's not correctly working, so. Oh, checking the manual. Connect the iron to the station. Use this button to up and change settings. In temperature mode, pressing this button will change the selected preset temperature while the unit is in operation. Holding the button will start the adjustment mode. Enter. This button will make and confirm selections. Pressing the button will display the current set temperature. Okay. Pressing and holding will start the temperature setting mode. Okay. Ah, here we go. 75. There we go. Now we're cooking. Let's see here. Let's see if this is melting anything yet. Okay, it is melting the solder. That's good. It's taking its time. Yeah, I seem to remember this this solder takes a while to get up to heat too. So let's try maybe 380? 85? Yeah, that sounds good. And have another drink. God, yeah, it just motors up. Okay, let's clean off that tip. You know, you were set around 600. I might just bump it up there like that. Why am I messing around with... So the longer you're applying heat, the worse it does for it. So I'm going to actually, yeah, let's start at 500 to see how that goes. Honest question, why pussyfoot around with lower temperatures? To avoid damaging the board. I guess the idea is that you, you know, if you make a mistake or mishit something or hold down too long, or if you've got specifically extremely temperature sensitive equipment, those are reasons. But yeah. Oh yeah, and the soldering tip is what is a good thing to damage too when you're going at too high a temperature. However, the results speak for themselves. Bonbons. Poison crispy owl. No, I'm not having an aphasia. Sorry, just in case anyone's wondering, check out the Butterfield diet on YouTube. Brian Butterfield. Maybe use a torch. Jeez. Actually, I should definitely tin that wire too. Okay, and then let's just mash those together. It's enough of a connection that it doesn't matter. It will hold. Am I going to heat shrink any of this, Bob? No, absolutely not. Not for this stage. Right now, all we're doing is connecting the cable up so that we can test it on the breadboard. When we're actually going for the full Monty, then yes, absolutely. Breadboards, or sorry, shrink tubing for days, should we need it. That maybe wasn't the smartest idea, but here we are. All right, let's get that. Oh, wait, you're not seeing that. Solder with the plumber's torch. I gotta say, the Amazon no-name special hot air station worked real well for that particular project. Also worked real well in getting a water ring off of my. Wow, I'm super out of focus. There we go. Hopefully that's better. Getting a water ring out of my wooden table, so that was handy. Click, 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 click. Boom, boom. Two, and that's my shoe buckled, as it were. Okay, let's go ahead and tin these wires up. This is an absolute joy, I've got to say. I held on to that broken ass USB pen solder iron for way too long. I appreciate your assistance in kicking my ass into gear with proper equipment. He says as he jams Molexes onto the back of a exposed XLR cable. Okay, thankfully they're color coded, so it's not going to be too difficult. Just get all the solder on we can. Hey, Johnny. Someone earlier, actually, I think it might have been, it might have been Fenriel made a good Moire shirt song. So. Or was that UMD? I can't recall. I have the mind of a goldfish. Okay. Whew. Good. Those are tinned. Let's get them connected to the end of the cable that is currently in my pantaloony area. Tiny, we're toony, we all wear pantaloonies. And in this cartoony, God, I missed it. Animaniacs are great, but sometimes you just want to slum it with the Tiny Toons. Tell me I'm wrong. Nice. That's a good join. I am wrong. Oh, come on. I mean, Babs Bunny, Plucky Duck, Mads Mikkelsen. That was the wrong cable. By Mads Mikkelsen, I mean Montana Max. Sorry. You know, all your favorite Tiny Toons. Mad Mikkelsen, the guy from all those movies with the Germans. You know, Tiny Toons. Of course, and the Freakazoid fans are just, you know, sitting on the edge of their seats in their homes waiting for me to mention them. I haven't seen Freakazoid, which I consider a personal failing, but come on. Merge with your friends. Wire. There we go. That seems a bit better. Because of course I don't mean Tick fans, and they know what they did. They got a live action reboot and all that. Then before Ian wondered why I didn't just crimp them, because the crimping materials are more expensive than the soldering, and this eats up time nicely. Hey, look, we're done. All right. I did say red was output 2, so red goes to red. Now you're dead. Green goes to yellow because I'm a monster. And brown goes to town, by which I mean ground town. Cool. There's not enough disk space sufficient for recording. I'm going to turn a soldering iron off there just to give it some, give it a rest. And then we're going to do the other side here. So brown goes to ground. Ground to ground, red to red, and green to green. Well, okay, let's get that microphone out. Now, I said before, we need to, because this circuit will no longer pass phantom power, we need to provide power to the microphone, and we do so via a double battery. And that is just now a straight up powered mic. Stick that back in there. Is the mic side supposed to be grounded or not grounded? I get the feeling it's all supposed to be grounded all the way through. I don't see why it wouldn't. Regardless, it should work. Okay, so just before we do anything else, let's grab another XLR cable here. And let's just remind ourselves, I mean, if it's not supposed to be grounded, I can just yank the cable off the, out of here, and then it's not grounded anymore. But let's get a reminder of what this sounds like. Shall we? Plug in the mic. Bleep blorp. Come on, computer, help me out here. Okay, back into the HN. Okay, so I'm currently talking to you from the overhead mic. I am now switching to the second mic. I am now right up on the microphone here. This is still 90%, 90%, not sorry, 90%, plus 90 dB on the gain going into it. So we'll find out what happens when we plug this new amp in, if this works. Switching back to the main. All right, folks, moments of truth. Hold on. I want to hear the difference, so I'm just going to chunk myself into what you're listening to right there as well. It's yep, line. Nope, leave that line. No, headphones. Perfect. Okay. Microphone. Where's my volume? Volume. Yeah. Techstorm says definitely turn down volume while I am literally cranking it up. Okay. Microphone connected. Good. Soldering iron out of the way. And let's bring this up, because we're going to need to plug it in. So plugging it in. Nothing is fried. Nothing is exploded yet. I'm not smelling any smoke. Good sign so far. All right, here we go. Turning off overhead mic, moving to regular mic in 3. 1, And here we are. Nothing's coming through. Okay. Are we all second? Okay. Hmm. Check, 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 check. We're not shorting at all. Are we shorting? We are not shorting. Oh, wait a second. That's not the right. That's the one we want. I was in the wrong hole. I don't know if this is any better. Is it better? It seems lower. It sounds exactly the same, to be honest. But that's fine because okay, let's swap it out here. Where's my cable here? I'm just gonna swap cables and then we're gonna see what it sounds like here. Ready? Oh wow, okay, that's interesting. That's okay. Here's another point. Let's turn off all of my filters that I've got here on OBS. So we're gonna turn off the noise suppression, turn off the compressor, turn off the gain. You're getting raw in here. This is this is not camera audio. This is same microphone, though not through the amplifier. So test 1, test 2, test 3. This is the same microphone coming through on. Oh, there's another mic in the room that's hot. God damn it! Okay. Let me see what that is. Because I'd set up, I'd set up some capture here so that you could actually see the difference. But it sounds better, but I don't know. Okay, hold on. I'm going to unhide and find out which other microphone is current. No, there are no other microphones that are currently that you should be hearing me through. They're all muted. Interesting. You're wondering how you could hear the plugging. That's so. Can you hear anything at all now? I'm not saying any words to you. And oh my, what is going on? Is it auto? What the what? Properties. You monster. You monsters. You absolute monsters. I've been going through a completely different. It's not a webcam. It's the it's the microphone on top of the goddamn Canon X205. Oh my. Okay. So that's so this is what the waveform looks like when I'm speaking into it through the filter. Let's swap out. This is now me speaking through the. This is me speaking through the microphone of the amplifier, and I don't know if it's. Is it? It sounds richer in my head. There needs less bass, plus 10 via the amp. Okay, interesting. Just because I'm curious, let's see what happens when we turn these FETs around, just for fun. Okay, I've reversed one of them, and I'm going to do the next one live. I'm just going to unplug that while I'm talking. plugging that back in, and ooh, that's weird. Now we're getting some sort of a phase inversion, it sounds like. I don't know if I like that at all, but interesting. Interesting. Okay. Gonna... Okay, so the circuit works. Hmm. Should we try soldering it up to see if it's it's worth keeping around? Because I would love to try this on another on a test by removing the ground. Yeah, sure. You know what? Let's do that. Here goes ground. Ground. Oh, okay. Ground gone. Ground gone. You know what? I think it's supposed to have ground because it works when I hold onto the ground from the other cable, but when I let go of the ground from the other cable, the sound complete the circuit. It comes back. That's super weird. Okay, how about if I don't touch anything? And then we're back. And now we're back in the land of Dairy Queen. And actually, to be honest, I think this actually sounds better. I kind of want to hear what it sounds like going into the or what if it works with this other mic that I've got. The other mic we've got here is the is an Audio-Technica non-marked. Oh, AT897, which is also phantom powered, but I believe not. Oh, it is also battery powered. So let's see what happens when you don't have battery power in there, just for fun. You think I'm bypassing the preamp? I wonder how that could be. Let's go. Resistors go into there to there. Maybe I am. Maybe I am. No, it doesn't. Doesn't seem like it. Oh, hold on. There is one. No, that's everything is looks like it's properly connected. Everything is a solid connection. If I remove one of these things, it just okay. Wow. So if you remove one of the resistors, that goes away. Putting that back in. Sorry about that. Brings things back down. Interesting. 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 So that goes to this. So just looking at, I'm just examining the audio files, or not the audio files here. Based on what happens when you yank the JFETs, it seems unlikely you're bypassing it. Yeah, exactly. Yeah. Huh. I mean, it's things are very subjective, but I guess let's see what happens when we switch mics to one that's not self-powered. So we're back on the overhead mic now, and that's wow, that's a difference and a half. And then here is, okay, if we're broadcasting in stereo, which I don't know if we are, you'll be able to hear this mic in your right channel and this mic in your left channel. And that's interesting. Here's the other thing too, is that this is not a mono for you. Okay, well let's cut this out because that's kind of ridiculous. Okay, I think I'm happy. Oh god, I need to unplug that. Whee! Yeah, I don't think you get stereo, though stereo does affect things. I know this because I had to change it to mono and got better audio recently. Yeah, you know what? Let's button this up and let's solder this up because I think this may work differently when you're using it on the type of mic that it's meant for, rather than just using it on a mic that is unnecessary for, because it does interestingly wrap the sound in a certain amount of warmth to it. Okay, for that then we're gonna need some breadboard. I think I've got some around here. Gotta check which box. I think I'm due for a complete reorganization of my various solder boxes here, because this is starting to get a little bit out of control. This is my box of what I consider to be microcontrollers and Raspberry Pis, and it's got a bunch of my Molex stuff in it, which is probably not the best place for it, but it also doesn't have the breadboard that I thought I had in here, so that's not it. Is it in here? Ah, here we go. It's in here with my other microcontroller stuff. Wow, sometimes you just have to buy way too many diodes. Okay. Now would you look at that? I haven't used barely any of that, or any of that. Oh, hey, wait. Better yet, I've got one that's already open. That seems like the thing to do. Oh, and I've got probes. I could have used probes instead of soldering things. Damn it. I want my probes back. Okay, what are we saying here in the chat? Especially that we're introducing raw gain without changing frequency response. Oh boy, this is going to be fun to clean up. Okay, let's disconnect the XLR abominations that we've got. I may need to resolder those to some different probes now that I think about it. And then I guess let's figure out how we've got this planned out. Similar style, I guess. I guess we should probably just start with... we should just start with the actual cables themselves. Because otherwise we might get mixed up. So this is definitely going to be the one for the inputs. How do we want to do this? Measure the project box to make sure the cut board is small enough to fit. That's a good start, Arclight. That's a very good start. Let's crack that sucker open. I'm pretty sure I've got those diodes for a keyboard project of some sort that I'm planning sometime in the future. Oh yeah, that's what we like. Perfect sizing. Okay. Now, let's think about planning this. 1, 2, 3 on the ground, 4 on the grounds. Oh boy. Thinking things out is hard, isn't it? Think about it this way. Input, then to... Is this even the kind of board we want to use now that I think about it? Fortnite, it's about to get down. Get down. Just something Tomato Town. Just solder it all in wires. Who needs a board? Yeah, dead bug it, right? That's my preferred way to do it. Dead bug it and then just cover it all in hot glue so nothing touches anything else. I mean, I guess let's work back from these two different work backwards from the JFETs. Okay, that seems fine. Okay. All right, I should get the circuit diagram back up on my screen here. Also turn the screen back on. And also fill up my cup, muzzle toff, etc. So, I mean, just putting it out there, audio-wise, which do you prefer so far? Audio coming from the camera or from the exterior microphone adapter? Yeah, I'm just really curious to see if this would work differently with a... You like the Rode? Well, too bad! You're on the Audio Technica right now. Arclight. I think the mic needs some EQ balancing. Oh yeah, definitely. And in fact, actually, I should add my... beep, boop, bop. Put the filters back on, and hopefully that sounds a little bit better now. My thought, and here's my thought. My thought is that this might actually sound a bit different when we're using an actual dynamic microphone rather than a condenser. Anyway, right. So, we get in. You know what? Let's take those resistors out again. In goes to resistor. Okay. Your resistor. Now, where does that go out to? That goes out to the... I mean, we might as well go... It goes out the ground, right? Yeah, let's use the central rail here as ground, because that sounds like a good idea. Don't forget the SD swap and migrating it over. Good call. Good call. Okay, and then this is going to be that hole. So that hole goes in like this. This is absolutely not how you're supposed to do it, but too bad. I can't be stopped. Thank you, Femoral. So yeah, if I'm working off that that sheet, okay, and then input 2 goes the other side to ground. Burn down Tomato Town. Sorry, I have been really jamming on Chug Jug these past couple weeks, and I can't stop, and I know it's a problem. And I shouldn't, but I can't stop. I'd really like to Chug jug with you. We could be pro Fortnite gamers. Pro Fortnite gamers. Okay, G to the middle. So that's going to be that one. Ugh. Gonna have to move these down a bit, actually. Maybe I should start with these things, actually. Okay, so let's use the forest out for, and G is going to be our signal coming in. Okay, good. Okay, and S is that side, so that goes to the out pin. Okay, let's put those over there. Okay, and then off of the G pin, we go resistors to ground. So resistor to ground. And then I'm going to go do the same thing on this side. Can I get two through? Oh, yeah, hell. Yes, maybe. Hell, maybe. Nope, can't through hole two things. So we'll just have to, I guess, double up there. Good enough. That'll be good. I'm doing this on the wrong side of the board, too, I just realized. Whoops. Bleep, blorp. Try again, Ian. Okay, let's move it right down to the middle there. Two holes on each side, because I think that's all I'll need. Let's just do one side of the circuit here to start with and see if that, hope it looks good. Okay, there we go. That's one in there. And then as I said, we get a resistor on the same wavelength, and that goes through to there. Okay, great. And then that's ground all the way to ground town. So next up is S, which is the right hand, or which is the, so we're going to go with D, which is currently on the right hand side. Oh my gosh. So S goes to the R68 resistor. And it also goes to ground. Okay. Just write it on the perf board. Oh, hey! Lady Brand Arch, welcome to the show. Hope you enjoy what you see and that you stick around. We're currently putting together a amplifier for dynamic microphones. Yes, dynamic specifically. Just thinking out loud there, just making sure. Am I doing the right thing? Yes, I am. Good. Whew. Okay, so that's one side. And then the other side goes to output. And just straight to output. So I think we can actually solder this up now, that I think about it. Let's do that. Let's make some soldering happen. And let's give that a little brush with some flux. Okay, dib a little dab will do ya. In the various areas. Okay. All right. These to the side. Good God, that heats up fast. That's almost illegal. You know what? You deserve to see the whole procedure. Let's get it right in there. Ooh, wow, that's not very good. Here we go. That's a good hole. Not bad there. Okay, too long there. Oh, so it is an op, or not an op amp, it's a JFET Class A amplifier, I believe. Oh no, what have I done here? I have done a crime. Oh God. I have done a real crime. Fudge. Well, time to get the wick. Good job, me. Just need to keep that space clear. Let's hope this will work. Hoping ready to run from the cops. Oh my God. Okay, soak it up. Hope to hell that you get a clear space between the two things. Okay, it looks to me like I've managed to separate those two joins, so we'll call that good. Could call that good. Be a bit more good with this in. Coming from the other direction. Okay. There we go. Jeez. It's probably the worst job I've ever done, but here we are. I'm going to test that, by the way, too. Okay. Now the FET. I chill in deep space. Unmask covers my face. I deliver the prize, but I have to narrow my eyes, because my time I don't like to waste. Get down. Question, reference, and enigma. Let's get inside a slave one. Find your homing signal for Endor off. Ripley to Spock. Didn't know the next line, but there's going to be a cost. See, my name is Boba Fett. I know I shouldn't say. It's not acting right. Etc., etc. Okay. How's that look? Really terrible, actually. This is some of my worst soldering job I've done, but let's use the camera to examine my work. Ugh. Lighting's bad too. Where's my continuity meter? I need to make doubly sure before I go even a step further. Oh, Dr. Dudeman, I have an easy answer for you there that might work better than trying to rewire your car. And I would suggest get on down to flap on down to the Apple Patch and check out your fuse box. Why, Delilah? There we go. Oh, thank God. Phew! No shorts. All good. All good. So the radio isn't plugged in, my multifunction screen doesn't work. Ah, you need the multifunction screen in addition. Well then, Godspeed, my friend. That's not going to be an easy one for you. Okay, those are all there good and solid. That's one side done-ish. Let's get to clipping. Clip some of this garbage off the backside. Looking good so far. I mean, it is occurring. Okay. So, we've got that one in. Now I need to do that again with another one. So, same idea. Let's go 2 from the side, and let's bring that over here. So we've got more space to work with. Three holes through. I probably want one more. Three holes through. Great. Resistor times. Center resistor goes to ground. That's this friend. It just goes in like this. Nope, gonna clean that. This is cribbage. Absolutely dub works. Absolutely cribbage. I want to clean these up, but it's not worth my time. I mean, let's do it anyway. There we go. Straighter wires. Through the holes. Secret, 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 secret tunnel. Okay. Slide it in. Just like that. Super Mario Brothers Super style. Okay. Uh-oh. Oh, the Merricat, I'm not going to be using this. I'm actually going to be passing this along to one of our, either the studio itself at Loading Ready Run or one of our friends who uses Sure SM7B. I didn't tin anything. or flux anything. So that's why nothing's sticking to anything. Oh, right, I still got one more resistor to get in there, too. And it goes from S, which is actually D. It goes from D? Yes, D goes to out. Did I mess this up already? No. D. Okay, D on that side. D goes directly to out. Huh. Yep. Mucked that up. Good job, me. So let's flip this one around. Okay, wait. D is on the left. D is the one that goes... Yep. Boo! Boo, 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 boo. Okay, I'm going to flip this one around. Bob, I'm glad to hear that you are also Daisy today. Okay. And D now needs to go to the resist. Wait. This side is D. Okay. D goes to direct out. Nothing happens on that. Resistor goes to S. Yes. Good. Got there. Figured it out. Just going to have to resolder one of the sides then. Needs to just... Oh, yeah. No, it's... I'm sorry about that. So yeah, I've flipped this one around so that it is now... flat side is facing me. So that means this side is D, and this side is S. And S is going to the resistor, like it should have. And then we'll just have to go back and fix the other one. Sorry about that. Zoom out there while I just pull that through. Now, which is going to be the easier thing to do? Desolder the one resistor, or actually, you know what? I know for a fact it's going to be easier and probably better for everything involved if we desolder the resistor rather than desoldering the component. There we go. That's a nice lay. Much better there, Ian. Much better work. Okay, let's coat this in flux. And let's get back in there. Whoa, wrong way. Too far. Minimum viable focal distance. You're not wrong, Arclight. This is actually extremely satisfying right now. There we go. That's what we wanted to see. Just an absolute mess of flux. Let's try this one again here. There we go. That's some good work right there. Down, nice. There, good. Good join on that one. Good. Not happy with that one, but that's a better join. Okay, 2 more pieces left. Good God, I'm not doing a very good job of these ones today. And then one more kind of through the forest there. Okay. Good and globby. And I don't see anything that's going to short, so that makes me a double checker. Happy camping double checker. Okay, let's turn it on. Test, test. No bridge. No bridge. Happy birthday. Okay, good, good. That's most of the resistors, and actually that's all of the resistors in place, isn't it? Okay, so now we just need to go fix that other side that I royally goofed up, and then connect all of the grounds together into a common grounding. And then button it up the rest of the way. Right, so we were going to desolder the resistor. So I'm just going to move that from that side to that side, because that seems like a much easier and much less involved desoldering. So let's just clip it some of that. God, I'm going to be spending so much time cleaning up this workspace once we're done here. Okay, that's good start here. Probably should have the solder sucker at home for times when this might be necessary, but this isn't so bad. Okay, so I think I'm going to have to give this some pressure on the other side. Aha! Toothpick. That's a perfect thing to shove under the end there. And that should provide just enough force to lift it out. Okay, that's one side out. Or is it? Okay, that's one side out. And the other side now, we can probably just... There we go. Pops out. Nice work. Straighten those tips, because we're going to need to get it through a hole again. Okay, that side. Kind of give it a twist a bit. Yeah. And then make sure you get the right side this time. So, resistor goes to the D side. the D side, but we want the S side, and the S side is this side. Ah! 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 Oh, hey, I have got tools for this. Why am I making this so hard on myself when it doesn't need to be? Probably because I didn't correctly bend the pins. There we go. That's in there pretty good. And now it's just a matter of soldering those 2 points back up. So let's hit it with the flux. Gonna have to refill that flux because it's getting close to the end of the brush tip there. Okay. Soldering iron remains wicked hot. Happy about. Good. Okay. It's good and appears to be non-bridgy. Ooh, barely poking through on the top side here. There we go. Okay, solid. Right. Next up. That's literally all there is to this actual circuit. Next up, I think we're actually soldering cable to this here, if I'm correct. So let's desolder these probe ends. Actually, you know what? This is probably worth just giving ourselves a fresh start. That. And this is the input. And then this is output. Let's give it another snip there as well. Okay. Let's set this aside for the moment. Let's start looking at this. Go. And do the same on the other side. That is a nice storm count. Pretty happy with that. Pretty happy with this too. Bang. Okay. All right, so let's get the ground wire out of the way and get rid of that plastic or that cotton thread too. I'm not a fan. And then we can just twist that over. Go. Find a way to get that through a hole, and then just trim these threads here. Good. Do the same on the other side. Learning is the strong word, and there's still time. Hey, I think this is going to be a fine show. Besides, learning only occurs if the information gain transfers over to a future stream. Lord knows I'm not going to remember any of this. That's a lie. This is really cool stuff. Wire stripper, where were you? Okay, click, click, boom. It's one down. Ooh, maybe we want to get some, nah. Also, all my heat shrinks at the moon base, so moot point there. No moot point. I mean, no heat shrink. No moot points. No moot points. Only heat shrink. All right. Strip him if you got him, which I do, and I have done. All right, let's work on the out hole now. Out hole, according to this, is coming off of D, which is one of the only non-resistored thing, and that is pin 2. Pin 2, if I recall, was the red pin. Just double check that on my own documents. Pin 2 is red. Perfect. So red goes to pin to the out. Okay. Oh my goodness. What have I done? Oh no, this will be fine. This will be fine. So I guess actually we can probably just snap this board at this point. Probably about here. Let's give ourselves another couple holes just in case. That seems good there. All right, here we go. Wait. Snap. Oh, that's satisfying. Yeah, no, the correct thing to do is just epoxy the hell out of everything when we're done. That way we can save our trade secrets so that, you know, no enterprising forum people can go onto a forum or crack open our work and examine just how we put this together and put together a circuit diagram that others can follow, you know. Where am I going with this? I'm going out. Out is... Wait. Yes, this is out. Okay, so out is post. That's the only thing that's got nothing on it. And I don't think it really matters which one's red and green because they're pretty much interchangeable at this point, if I recall. So let's just dust them up with our good friend Flux. Is there enough space to get all the way across like that? Maybe if I split this this cable just a bit more. Okay. Oh, there we go. That's plenty of space now. And now my fingers are covered in flux, which is perfect. Exactly what I want. Yes. Okay. Let's do this. And then the other one goes across. Oh, wait, I could probably do it down the center, or at least the middle. Yeah, let's get the middle. So let's, okay, wait a second. Am I going out? This is out. This is out. Yep. Okay, everything's fine. Let's solve these one at a time here. This one. Oh, no. Wait, I can do this. This has been a very useful piece of equipment for me, specifically for this sort of thing. Okay, hold that. Ah, dang it. Everything's sticky. Flux. I want to make sure we didn't have a bridge there, which I think we might have. Whew. Gotta keep remembering to use that. We have this holder now for the solder. Best make use of it. Where do you go? Hey. No bridging. All good. All good. I can always label it. There's marker not adhere. I mean, it's a very small thing too, so it's a little bit difficult. But okay, let's get that other side over there, and it's going to be about here. Oh, this is rough. Okay, that's in the right place. Perfect. That, geez, what the hell is going on there? That was a short and a half waiting to happen. Pin just flying around. There we go. It's a bit cleaner. Not overly, but a bit. Okay. Get through hole. Yeah, braided wires through holes are not fun, nor is keeping them there in position while you solder them in place. That is a solid join. Thank God. Oh, I do love a good soldering job, but this is ridiculous. Okay. I'm gonna stick you here, and then you're gonna get to the main center hole through. You know, I'm just gonna solder you on the bottom of the back. Like this. Perfection. In fact, I'm actually going to do that on both sides because that's going to make it much easier to connect to the grounding to the back end. Okay, next side. Because I probably want to trim this ground strip too. All right. I really don't want that song stuck in my head. Okay, those are the outs. This is the in, and ins are on the middle. So we're definitely going to need more wiring again. Where's my blade? Very carefully, just hit a big start slice. Use the wires to... Nope, don't use the wires to pull it open because you didn't get it far enough. So give it a bit more. There we go. That feels good. Open her up. Twist that ground a bit more. Get it nice and clean. Okay. Now I think we've got space to go through here. Make sure those end bits are twisted for through-hole possibilities. And then don't forget to flex them, because that's, as long as we can get them through the hole, useful. There we go. Yeah, if I end up doing this at scale at all, I'm definitely going to be getting some proper project boxes and just straight up XLR connectors rather than trying to wire this inline into a cable, because this is problematic. Jim, how are these getting through the holes? We'll probably just clip entry holes at the bottom there, and then that's I mean. Yeah, you know, drills and widen the hole might work too. But it's soldered now, and there's nothing I can do about that, so... God, yeah, machines do everything better than humans do. It's just truth. Machines should do the work. People should think. Machines should work. That's what they're good at. People should think. That's what they're good at. Also, no one should work. Right, I just gotta match sides now. That's the key. Red to red. Okay, get that close enough to the solder. Let it just stick, and then apply solder to wire and to copper. Once it's tinned, I can kind of get in there a little bit more proactively, but getting it enough to tack in place is hard enough. Yep, don't touch that with your fingies. Okay, that's in there. You can't see you'll be able to cut with a board in the middle wrapped in packing tape. Who needs a project box? There's not many of us, but I mean, this is potentially going to be used in a studio setting, so we might want a project box. We might just want something. Okay, that's side 2. Again, with the... Get that down. This is the ugliest soldering you will ever see me do, probably, he says, before you probably gets... You know what? There's no guarantees. No guarantees at all. This might be the ugliest soldering you ever see from me, but there's a good chance that it won't be. God. Okay, so that's solid. Next step, as we said, we need to get those grounds on the other side, and that's probably what's going to hold us in place the best. I'm going to trim some of that right now. Doesn't need to go that far, but it does. I do like it going a distance. I can go the distance. Just enough to tack it in place. And we can really... There we go. Now I can really flood it. The nice thing is this will actually also provide some strain relief, which is kind of useful. So let's just get to adding solder. In the ugliest way possible. Yeah. Just bathe it. Molten lead. Molten core. Well, actually, rosin core. Yeah, I'm not sure if I like this proto board, but... Coreflux, why not get a helping hands? Eventually, yeah. I'm actually looking into potential candidates for helping hands. Specifically, not helping hands. What I want to get myself is a set of... what do you call those bad boys? A vice. Because I think a vice is going to be a lot more useful in the end. In terms of just... Nope. I should flux the hex out of this. The heck. More flux. Always, always, always more flux. Oh yeah, the Maricat. No, people. I did notice that people were doing the PCB shipping thing, and it was. But that's not. Well, I mean that is kind of what this show is about, isn't it? But we'll get. That's not what this episode is about, in my opinion. There we go. That'll do it. Jeez. Use the tools you have. And untangle the tools you have from each other. There we go. Okay, now I can probably get that in a little bit better. I need another locker to lock you fully where I want you. Get thee to their position, God of Cookery. Okay, there we go. Now we can just put solder down. Just coat that. Okay, and then I think I can trim that extra bit that's going over the edge. There we go. And we just need to bridge those two connections down the middle there. with a big old pile of solder. Oh no. Oh no. I may have made some big mistakes here, but nothing some soldering wick probably can't take care of. Yeah, no, people have been trying to get me to design boards in KiCad. The problem with that is it's just, it's fun to design, but then you get it board shipped and then you populate it, or maybe you actually have it pre-populated on their end, in which case there's not really much of a stream there, isn't then there is there. And when it comes to doing things like designing it, I mean, I'm not an electrical engineer. I'm not I'm not saying it's not going to happen. I'm just saying that I'm going to need to learn some stuff before I can make it happen. Really, I want to say, reliably. God, what have I done? Okay, I can't see that because the light's terrible. Real Galaxy Brain is to do it in stud.io. Okay, have I effed up really bad, or is it? Yep, still bad. That's thankfully not bridged, but actually, wait, is there anything on that? Okay, so partially safe, but I do need to still bridge these sections here. So let's see if we can do that with some sick solder. Where's the iron? Get out of here. I'm just going to use that as just a way of holding the whole thing down. Double clamps like that might just be enough too. Okay, and another blob in there. Should be enough to bridge that shit up. And again, hopefully, let's check for shorts first before we put this away, because this is ugly as sin. First of all, I don't think we have a full continuous ground, which I find odd. Not quite enough there. Oh, wait, I think I got it. Contiguous ground. We're good. Let's make sure that nothing else is bridged that's not supposed to be. These two are separate. These two are separate. partially separate? Oh no. Okay, I need to clean that area down there. Right there. Yep, that's a bridge. Think that got it? No. Hard to say. Have to ask. Have to check. Oh. I mean, wait a second. Those might need to be connected anyway. Nope, those are not connected on the other side, so that is a bridge somewhere. Well, let's add a little braid to there. Womp womp. Suck up some extra solder that's not needed. Get those clamps back on. Okay. Let's see. Otherwise, I'm going to have to find a magnifying... Oh, wait, I have a magnifying glass. It's in my phone. Everyone has one. Accessibility options, people. Use them. Because we'll all have to use them at some point in the future anyway. Okay, and then you can lock it. Ooh. And I think, you can see there, I think I'm free of bridges. But there might just be a tiny one. That's the thing. All electrons need is the tiniest excuse to jump over. But that's good. We got that. Okay. No bridging there. No bridging there. No bridging there. No bridging there. I think that circuit is complete. Let's test it out. We know it's not going to sound any different, but at least we can see if it will output. Where's my other cable here? Okay, and if that's the case, then we might just put off project boxing that for either another show or another time. But let's see what this does. We'll get into number 1. All right, switching over to different audio in 3, 2. Okay, that was weird. Something's up here. Ah, that's right. It's all attached. Phantom power? Phantom power is engaged. It should be. All right, well, let's check my... Oh, wait a second. Now, hold on a second. Let's do some continuity tests, just to make sure we're all good. Where is my tester? Oy, oy, oy. Gonna make ramen in a few minutes, too. All right. Pin the first is pin, if I remember correctly, let's just double check ourselves, pin on the female side, pin 1 should be green. So that means it should come through to that point. Is it coming through? He said as he pokes at things. Huh. Let's try it again. Oh, wait, there we go. Which cable was I connected to? That's cable 3? What is going on here? Okay. And then this one is... That should be cable 2. Not connected. What in the hell is going on here, folks? Okay, that's correct. Cable 2 is correct. And cable 3 should be... Three should be... One should be ground shield. Is it? Okay, 1 is ground shield. Good. And then 3 is... the... Okay, so that's correct. At least I think. So pin 3 to pin 3. Yep, all good there on the inside. How about the outside? Thankfully, this one has holes I can stick things in. Okay, pin 1 on the other side. Pin 1 on male is ground. So ground says, hallelujah. Pin 2 is red. Coming at you. Contiguous. Okay, and that means pin 3 should be negative cold. Coming from the other side. Okay. So that's correct. Oh, wait a second. When you said phantom power, did I have the battery's still in there, but it may be dead. So let's just get a fresh battery. Let's double check. Let's be thorough. Up. Oh. PC internals. Batteries. Stick it in the used section. Let's just grab a fresh Kirkland. Fresh Kirkland Alkaline AA. Plunk it in. Screw it back up. And I don't believe I'm doing a vacuum tube amp, but I mean, something, unless you know something I don't. Okay. Ugh. Choked back in. And let's try this again. Off. I need to know what we're hearing here, because this is super weird. Okay. And no, that's all just big fuzzy right there. And that's not that microphone either. Okay, well, that... New year, new projects. I don't know what's up with this, but I think there's some troubleshooting that can be done. And we might want to look into it in the future. But I think we've done... Honestly, I think we've done about everything we can here. So, cool. We had it working earlier, and now we don't. Boom! Well, what am I going to do here? I think what we'll have to do is come back and revisit this on a future stream, because I'm starting to power out here, and I'm going to make some bad decisions soon if I don't do that otherwise. That said, yeah, let's keep plugging at it. Let's keep seeing if we can make this work in the future, and then maybe we've got some bonus stuff as well. But that said, hopefully we'll. I want this to work. I want it to work badly. Maybe what I'll do is I'll source a dynamic microphone to test with for the next stream that we do this, and that way we'll know what's up. So yeah, thank you everyone for the stream. Thank you everyone for your generosity here over at twitch.tv/loadingreadyrun or over at patreon.com/loadingreadyrun. Jeez, stuff around here. Where is the notifications? Oh, yes! Also, have to thank once again Merle for the soldering iron. This is going to make projects a lot more pleasant to do. Oh, before I do anything else, let's just heat that back up. And then let's give that a proper cleaning and retinning so that everything is hunky-dory. While I do that, I want to thank all of y'all for your kindness and support here at the channel. Oh god, things are coming around on their own, senpai. There we go. Yeah, we'll figure this out. We've made it work once before. We know it can work. We just don't have it working right now. Give me some solder. Continue. Get coated. All right. And now, power on. Okay. Thank you so much, everyone, for your bits and subs. I would like to thank specifically Real Gamer Cow for 87 months, not 91, but respectable. Very much so. Me there, subscribing for 40 months with a lot of those cat faces. Love that stuff. Thanks to 62MG Cobra for 27 months of resub. Thank you for your continued support. Slow down, Ian. Dragon Knight, 32-month subscription. Thank you for your support of this channel and of Tinker Tailor Soldier Fry in particular. Ash Burnham coming in with 66 months. Always a delight. Have some Bezos bucks. I appreciate Bezos's bucks. We really could use, all of us, a lot more access to Bezos's bucks. Mr. J. Witt subscribing. Thanks to an anonymous gifter. Thank you for that. UWD John, subscribing for 26 months, been working in audio consumer electronics for 20 years. Happy to see you working on this. Oh boy, I hope I didn't disappoint too much, UWD, but thank you for being in the channel, and thank you for your support monetarily, and your support with your mind and your words in this project. Fellrender, brand new subscriber, thanks to an anonymous gifter. Welcome to you, and thank you for that gift. Coil Twitchbot, sharing with 100 bits, thank you. Monkus Be Funky, subscribing for 65 months, thank you for your continued support. Anubis169, dropping their 87th month of sub on the wall, 87 months of sub. Thank you. Prancer Inflatable Reindeer, 25 months. Oh, the moire on Ian's shirt is crispy. Sure is. Sure is. Sky Strike, subscribed for 52 months. That's 1 full year in weeks. Thank you. Joe743 is a 26-month subscriber. That's 2 more hours than there are in a day. Thank you. Thanks also to the Passerby for subscribing for 47 months. I missed the end of Let's Draft. I keep losing my streak by a day or two. This is my 46th month in a row, technically. I believe you, and hey, the system works. The system is working. Nolly3 joining us for 41 months. Thank you so much, Nolly, for that. Nudie Branch Art has subscribed thanks to the Americat. Thank you both for that. 62MG Cobra subscribed for 27 months. Did that come through twice? That's weird, but cool. Sure did. Yep. Cool. Zach Tenskadi. I'm going to say I got that there. Thank you for 27 months of subscription. And Malfunct for your 86 months. Man, I really hate stripping cable like that. Me too. Let's try to avoid doing it in the future together. BK Dragon Tech subscribing for 44 months. Wow, 44 already, huh? It happens fast, doesn't it? Coreflux, whoops, with 100 bits, throwing the bits. Xanto69 throwing the bits to us as well. And Banreal with 300 bits got here late, but VOD time. Enjoy the VOD. It's been kind of a ride. I'm excited to see what comes out of it when we eventually get it working. Not King nor Able coming in with 500 bits. Fun time, reminded me of the electronics classes. Good times, good times, good times indeed. And good times and good night to you all. Yeah, I don't know what's happening tomorrow. It's you can check it out over at the loadingreadyrun.com/live is where the schedule is. Our VODs live over at youtube.com/loadingreadylive. Loadingreadylive.com is the page where you can go to find out about everything we do and links to everything else that we do. Check me out over at tilty.house. Put that in your browser bar and get links to everything I do. And we will see you in a fortnight for something probably different, but we'll see when we can slot this in regardless. Thanks so much for joining me, chat, and as we say every time, I guess it certainly happened this time, ever forward, never learning. Good night.